Hello everyone, I am Adya from Sri Venkateswara College of Engineering from CSE department. Today I am going to give you all a presentation on binomial distribution. Contents. Introduction. Negative binomial distribution. Binomial distribution formula. Binomial distribution mean and variance. Binomial distribution examples. Binomial distribution versus normal distribution. Properties of binomial distribution. Real world applications of binomial distribution. Conclusion. Introduction. In binomial probability distribution, the number of success in a sequence of n experiments where each time a question is asked for S no, then the Boolean valued outcome is represented either with success or S or true or 1. Probability P or failure or no or false or 0. Probability Q is equal to 1 minus P. A single success or failure test is also called a Bernoulli trial or Bernoulli experiment, and a series of outcomes is called a Bernoulli process. For n is equal to 1, that is a single experiment, the binomial distribution is a Bernoulli distribution. The binomial distribution is the base for the famous binomial test for statistical importance. Negative binomial distribution. In probability theory and statistics, the number of successes in a series of independent and identically distributed Bernoulli trials before a particularized number of failures happens, it is termed as the negative binomial distribution. Here is the number of failures is denoted by R. For instance, if we throw a dice and determine the occurrence of 1 as a failure and all the non-ones as successes, now we throw our dice frequently until 1 appears the third time, that is R is equal to 3 failures, then the probability distribution of the number of ones that arrived would be the negative binomial distribution. Binomial distribution formula. The binomial distribution formula is for any random variable x is given by the following formulas. Binomial distribution, mean and variance. For a binomial distribution, the mean, variance and standard deviation for the given number of success are represented using the formulas mean mu is equal to np, variance sigma square is equal to npq, standard deviation sigma is equal to square root of npq, where p is the probability of success, q is the probability of failure, where q is equal to 1 minus p. Binomial distribution examples. As we already know, binomial distribution gives the possibility of a different set of outcomes. In real life, the concept is used for finding the quantity of raw and used materials while making a product. Taking a survey of positive and negative reviews from the public for any specific product or place. By using the yes or no survey, we can check whether the number of persons views the particular channel. To find the number of male and female employees in an organization, the number of votes collected by a candidate in an election is counted based on 0 or 1 probability. Binomial distribution versus normal distribution. The main difference between the binomial distribution and the normal distribution is that binomial distribution is discrete, whereas the normal distribution is continuous. It means that the binomial distribution has a finite amount of events, whereas the normal distribution has an infinite number of events. In case if the sample size for the binomial distribution is very large, then the distribution curve for the binomial distribution is similar to the normal distribution curve. Properties of binomial distribution. The properties of the binomial distribution are there are two possible outcomes, true or false, success or failure, yes or no. There is n number of independent trials or a fixed number of n times repeated trials. The probability of success or failure remains the same for each trial. Only the number of success is calculated out of n independent trials. Every trial is an independent trial, which means that the outcome of one trial does not affect the outcome of another trial. Real-world applications of binomial distribution. In finance, binomial distribution is used to model stock prices and calculate the probability of a certain stock price at a future date. This information can be used by investors to make informed decisions about buying or selling stocks. In marketing, binomial distribution is used to predict consumer behavior and measure the success of marketing campaigns. For example, a company may use binomial distribution to calculate the probability that a consumer will purchase a product based on their age, gender, and other demographic factors. Limitations of binomial distribution. While binomial distribution is a powerful tool for modeling and analyzing data, it does not have its own limitations. One major limitation is that it assumes that each trial in the experiment is independent and identically distributed. This means that the outcome of one trial does not affect the outcome of another trial, and the probability of the success or failure remains constant across all trials. In real world scenarios, this assumption may not hold true, which can lead to inaccurate results. Another limitation of binomial distribution is that it is only applicable in situations where there are a fixed number of trials, and each trial has only two possible outcomes, success or failure. If the experiment involves more than two outcomes, or if the number of trials is not fixed, then the binomial distribution may not be the best tool to use. Conclusion. In conclusion, we have learned that binomial distribution is a powerful tool for understanding and predicting the outcomes of binary events. By breaking down complex scenarios into simple success or failure probabilities, we can make informed decisions in fields ranging from finance to sports. We have also explored key concepts such as binomial probability formula, the binomial distribution function, and the relationship between binomial and normal distribution. To continue learning about binomial distribution, we recommend exploring related topics such as hypothesis testing and advanced probability theory. Practicing with real world examples and problems will further solidify your understanding of this important statistical tool. Thank you so much for watching my presentation. If you liked my presentation, please do like, share and subscribe.